So as I noted on the last slide, right, once we start thinking about goal abstraction and sort of all of these functions or modules or procedures running at the same time, what you really have done is turn this into a problem of arbitration. By the way, this does have a name. I really like the name. It's called modular reinforcement learning. And that just sort of captures the idea that we've divided the world into a bunch of modules, or what we might call options, or what we might call temporally extended actions. And these things always have associated with them goals. They're always trying to do something or to accomplish something. They're different modules. And we're the operating system, and we need to decide which program we're going to let run next. And there are lots of ways you might imagine doing this. Here are three of the more popular ones, each of which has strengths and drawbacks. And they're kind of the things that you would come up with if you were given 5 minutes on a test to come up with something. So here are the various arbitration techniques. So the simplest one is greatest mass Q-learning, which, well, Michael, what do you think that means?
It means greatest mass Q-learning. So we have Q functions maybe for each of the individual subtasks, and we say, well, whoever's got the highest Q value gets to take the next action.
That's close. So the first thing you said is right. Since each of these things are their own little goals running around, they're like their own little RL bots or agents, then each of them has a Q function. And what greatest mass Q function does is it adds up all of the Q functions. So for the state that we happen to be in, add up the Q value for every state action pair, and whichever one is the largest, that's the one that we execute.
Wait, hang on. So I was saying whichever Q function has the largest value. You're actually saying which action after combining the Q functions has the largest value.
Right. So
it's sort of like they're voting.
That's exactly right. It's exactly like they're voting. So I say that the Q value of taking a particular action in any state is actually the sum of all the Q values for each of the agents indexed here by I.
And then
I just pick
we go greedy.
Yeah, I pick the action that has the most mass across all the agents.
Okay, so then why is it Q-learn? Why isn't it just greatest action mass or something?
Well, the reason you have it as Q-learning is because you assume there was Q-learning going on, and you're using the Q function to determine how to vote. So that's exactly why it's called Q-learning, because there's a Q function involved. So this is adding everything up, and it does sort of exactly what you would expect. But basically, everyone votes, and whichever has the biggest vote wins.
So I want to say that the modules are voting, but they're voting on different actions, and whichever action has the largest number of votes wins.
Right. I'm sorry. That's what I meant to say. What did I say?
Okay. Well, it sounded like, it was interpretable as the whichever Q module gets the most votes gets to decide.
Oh, I'm sorry. Yeah. So that's actually closer to what you were describing.
Yeah, I know.
But yeah, so here all you're doing is you're voting for each action. That's the greatest mass Q-learning, and you just go from there. And that's neat and kind of makes sense if you assume sort of they're all care about some ultimate goal together. But people have observed that could be bad because it might not be good for any particular agent. Right? So imagine that I have a couple of, I have 10 agents, there are 10 actions, and each one strongly believes in a subset of those actions, but they're different ones, so each one believes in a different action. And so, or better yet, there are 10 actions and there's 5 agents, and there's an action that is the 5th choice of every one of those agents, but because it's the 5th choice of every one of those agents, it's the one that ends up getting the most mass. And so you haven't really satisfied any of the sub-goals.
Yeah, I mean, I could see that as being a bad thing, or I could see that as being a good thing, right? Because it's choosing that action not just because it's bad. It's choosing that action because it makes everybody a little happy instead of making some people really unhappy.
Right, but you can construct examples where sort of everyone's least favorite choice will still end up being the one with the most votes if nobody agrees on anything else. But that's okay. I mean, it's still, as you say, it's a reasonable thing to do under lots of circumstances. There just happen to be cases where it doesn't always work, which would, there's no free lunch. So it's not surprising that that's the case.